Hello, my name is Dave Farnia, and today we'll be starting a new seminar series in JMAG. Today's seminar is going to cover JMAG-Express, and we'll learn how it can become an easy and fast motor design tool. Future webinars are going to deal with topics ranging from 3D motor design in JMAG all the way to efficient use of the pre- and post-processor. In today's webinar, we'll go through a brief overview, then talk about the structure of JMAG-Express. We'll start with JMAG-Express Quick Mode, which can output results in just seconds. We'll look at how Quick Mode works, its calculation speed, and precision. We'll also see how studies can be used based on predefined templates in JMAG-Express. We'll also see how to modify these existing templates. Next, we'll move into JMAG-Express Power Mode. We'll see how its setup is the same as Express, but learn how it is backed by the full FEA capabilities of JMAG Designer. We'll learn how Power Mode works, examine its calculation speed and precision. We'll also see how reports and database searches are used in the dashboard. We'll also see how comprehensive results can be evaluated in JMAG Designer. We'll also see that the actual model itself can be moved into JMAG Designer for further analysis. We'll then look at the JMAG-Express license structure and conclude with a short summary. JMAG-Express represents an effort to distill 30 years of machine modeling experience into an easy-to-use tool that will help you design rotating machines. With JMAG-Express, you define the known properties of the machine, such as the geometry and materials, and then JMAG-Express generates the mesh and outputs the machine performance data automatically. This means that you do not need to know how to set up the FEA model. JMAG-Express is going to take care of that. This seminar's target audience is anyone who would like to standardize their machine analyses, and the benefits of this seminar are learning what JMAG-Express can do for you, as well as learning how to correctly set up a model. First, let's take a look at the structure of JMAG-Express. So let's take a look at the JMAG product line. The first product in this lineup is actually JMAG-Express. JMAG-Express is the first product mentioned because it is so easy to use. It's template-based analysis that all you have to modify are the parameters of the template, and JMAG will actually take care of generating the results and setting up the actual FEA model. For more flexibility, you can move into JMAG Designer. JMAG Designer can take the models from JMAG-Express to do further analysis, or you can actually generate a model completely from scratch. Both JMAG Designer and JMAG-Express can work with JMAG-RT Motor Modeler. The JMAG-RT Motor Modeler is a way to capture a motor's performance in a lookup table format. This lookup table can now be brought into JMAG-RT Viewer to generate torque speed curves and efficiency maps, or into software-in-the-loop simulations to do controller modeling, or hardware-in-the-loop simulations to actually test physical hardware. Another product in the JMAG lineup is the embedded version of JMAG in CATIA V5, as well as links to programs such as Abacus for thermal and structural simulations, and LMS's Virtual Lab for noise and vibration simulations. JMAG provides a variety of tools for machine development at every phase, starting with concept design and going all the way into the final detailed analysis. In that first concept design, JMAG-Express Quick Mode can provide results in just a matter of seconds. This will allow you to quickly iterate on numerous designs and evaluate which designs are going to be the most promising. Once you've settled on the most promising set of designs, you can move into JMAG-Express Power Mode for more comprehensive analysis, or directly into JMAG Designer for, again, complete FEA analysis. JMAG-Express Power Mode is effectively a front end for JMAG Designer. So in JMAG-Express Power Mode, it looks the same as JMAG-Express Quick Mode, where it's a template-based setup, but instead of being result output in just seconds, it's actually a full FEA calculation where JMAG-Express Power Mode takes care of the settings for the FEA analysis and then outputs the results automatically. All these tools can also work with JMAG VTB or Virtual Test Bench. Virtual Test Bench is a tool that can apply an analysis scenario to a model, and we'll learn a little bit more about this when we examine JMAG-Express Power Mode. JMAG Designer can also work with the model-in-the-loop, software-in-the-loop, and hardware-in-the-loop simulation systems and other CAE software. So as you can see, the JMAG Toolchain allows a lot of flexibility and a very comprehensive system for complete system modeling. The objectives of JMAG-Express are to easily obtain precise results. We also want to make sure that the results are obtained quickly. And we do this by simplifying some of the laborious geometry creation and condition settings by using the template, and we also simplify repetitive results processing by outputting the results automatically. If the results are quick, it's one thing, but we have to make sure the results are also accurate. And to obtain accurate results, we need to make sure that the precision of the type of JMAG analysis matches the type of study we want to run. So for instance, JMAG-Express Quick Mode outputs results in just seconds. So this type of analysis is very good for getting a rough idea of machine performance, whereas JMAG-Express Power Mode is a full FEA calculation, so it's meant for a more comprehensive analysis. Obtaining correct results also means that we have to take into consideration a wide variety of physical quantities, such as steel properties and magnet properties. The easy, fast motor design tool that can meet these demands is JMAG-Express. JMAG-Express is template-style analysis. The first step in setting up your JMAG-Express model is to choose the motor type. And we'll get into this in a few slides when we actually open up JMAG-Express and set up a model. But for now, we choose the type of motor and then define the actual precise geometry for both the stator and the rotor. Once we've done that, we can move into setting the conditions, where we can set the geometry conditions, the material properties, the winding conditions, and the drive settings. JMAG-Express uses high-precision solvers and meshers that are focused on motor design. The analysis is completed within seconds within Quick Mode, whereas Power Mode provides high-precision results. So again, once we set up the model in JMAG-Express, we can choose whether we want to operate in Quick Mode and output the results very quickly, or operate in Power Mode to do a higher precision analysis. If we look at Quick Mode versus Power Mode, there's a few differences. So in the JMAG-Express environment, we have JMAG-Express Public, which is free for download on the JMAG International website. Next, we have specific licenses for JMAG-Express for Quick Mode, which again outputs results in seconds, versus Power Mode, which is basically just a front end for JMAG Designer. Both Quick Mode and Power Mode can interact with JMAG Designer to do a more detailed analysis and recalculate the results that are brought in from JMAG-Express. But working in JMAG Designer requires special JMAG Designer licenses as well as solver licenses. JMAG-Express Quick Mode. Output results in just seconds. The analysis method in Quick Mode is based on what I would consider more of a finite element / lumped parameter type of method. So we're adjusting the solver's calculation parameters to really increase the calculation speed. As you can imagine, when you're outputting results in only a matter of seconds, it's not a full transient-based FEA, but it is an FEA-based analysis. We can also tune the mesh generation to increase speed. We'll set parameters for a balance between precision and speed. So again, we're trying to calculate results quickly without making the results meaningless. So we feel that the results are still a good general approximation for machine performance, but they're generated very quickly. In JMAG-Express, we also make use of an extensive material database, which has properties for magnets and silicon steel from most major domestic and overseas manufacturers. Again, the goal of JMAG-Express is to allow you to focus on the motor setup, while JMAG is going to take care of the calculation know-how. In Quick Mode, we can see that the analysis are obtained quickly. So we simply input the template parameters, click the light bulb, and then generate the results. And again, in a few slides, I'll be able to stop and then we'll take a look at this in practice. Geometry evaluation, besides just permanent magnet machines, it is possible to use specialized topologies for SRMs and induction machines. In Quick Mode, the results are outputted in a display screen, and we see basic output parameters such as torque versus current properties and torque versus speed properties. We also see D and Q axis or phase inductance, as well as a distribution of magnetomotive forces which could potentially cause harmonics. We can also look at iron loss, copper loss, and other efficiency factors, and see the relationship of current and voltage needed for the drive. If we look at a comparison between torque versus current in Quick Mode and Power Mode, we can see that Quick Mode, the torque coefficient is calculated from no load flux linkage, so it's linear, so there's no saturation effects. Whereas in power mode, since it is a front end for a full FEA, we can see the effects of saturation. This also shows up in the D and Q axis inductance, where the quick mode is not going to have those saturation characteristics that power mode is going to show. So again, within quick mode, we can do a very quick analysis over the rated range, but we can't do a detailed evaluation of torque and current properties, and we can't evaluate things like cogging torque and slot harmonics. But these types of analyses are possible within power mode or JMAG Designer. In JMAG-Express Public, we also have the option to do a sensitivity analysis, which allows us to actually pick an output parameter such as torque, and then see how the various parameters in the model affect that output parameter. So again, we can determine the sensitivity of those input parameters based on what the output parameter that we chose is. So again, if we're looking at torque, we can see that items such as outside diameter or magnet thickness are going to have the largest effect on our output torque. Within all JMAG-Express packages, there is a sizing function which can allow you to modify a geometry automatically. So for instance, if we are taking our initial model and it's perhaps a 1 kilowatt output power, but we want to size it up to 1.5 kilowatt output power without going in and determining what the exact geometric properties are, we can use the sizing function, which again will scale it up or down based on the size difference between the model that we have and the size that we're going to. One of the benefits of JMAG-Express is that the models can be analyzed again in JMAG-Express, or they can be exported directly to JMAG Designer for more comprehensive finite element analysis. Input and output files in JMAG-Express are based on CSV, JCF, and DXF formats. So if we're applying data, we can actually set it up as a CSV file and then import it into JMAG-Express to set up the model. Output data can be also exported as a CSV file that can be read into programs such as Microsoft Excel. The geometry for a JMAG-Express model can be output as a DXF file. JMAG-Express can also generate JMAG-RT models. So the JMAG-RT model is again a way to link into a control or circuit simulators. JMAG-Express is limited in that it can only generate a DQ model, so it's not as comprehensive as some of the capabilities of JMAG-RT for generating fully harmonic-based models or phase-based models, but it's still a step up from the basic constant parameter model that are available in most of these control simulation packages. These RT blocks are useful for evaluating control models or creating efficiency maps. So, I'll summarize JMAG-Express Quick Mode, and then we'll actually take a look at generating models in Express. JMAG-Express Quick Mode is a tool for calculating motor properties instantly. Its setup, again, as we'll see, is done in just minutes, and results are output in just seconds. So it's based on template-style parameters for calculation setup, including motor creation, material properties, and drive conditions. The results are still based on JMAG's high-precision, high-speed solvers, and what I would consider maybe a medium precision analysis is possible in JMAG-Express Quick Mode, and the option of doing a high precision analysis is possible by going either to Power Mode or into JMAG Designer. So what we'll do now is move over into JMAG-Express and take a look at generating a model in Quick Mode. As you can see, the motor library has a selection of common machine topologies, such as brushless motor IPM, brushless motor SPM, brushless motor outer rotor, induction machines, switch reluctance motors, brush motors, and universal motors. If we take a look at the brushless motor IPM, we can see that we have some basic setups, but we also have the capability to build a new combination based on a rotor and stator geometry. So we can choose from any variety of rotor geometries and stator geometries and set the model up based on these custom geometries, or again, we can choose some of the default geometries that are already available. If I select that first geometry, which is our most basic study, we can see that the actual model is going to open up. In this model, I can now change the geometric properties. So I can change the number of slots, outside diameter, inside diameter, and even the rotor properties. If I wanted to go in and add certain features such as perhaps a fillet or one of these backed iron teeth, or modify the geometry of the magnet slightly, I can actually click on this Modify button, which is going to open up the DXF geometry file, which I can then go through and modify. At this point, I won't get into that detail of an analysis yet, but again, the geometries are fully modifiable in JMAG-Express. So for now, I won't change any of these properties, but let's take a look at that sizing function. So let's say the desired rated output power, we'll change it from 1 kilowatts to 1.5 kilowatts. We can also limit certain parameters such as the maximum outside diameter of the motor, maximum motor height, power supply voltage, max current, max torque, max revolution speed, the type of winding, or the type of magnet. So I won't limit anything now. I'll just say that I want to modify the motor and bring it up to 1.5 kilowatts. I click apply, and we can see that the model geometry has been changed. So now that my output power will match 1.5 kilowatts. Besides the geometry, all the other material, winding, and drive conditions have also been changed to match that new geometry. So what I'll do is I'll go back to the original geometry, minimize the sizing function, and then we'll look at the other tabs. So right now we're in the quick mode. We can also do just a geometry and conditions if we just wanted to take a model into JMAG Designer for full analysis, or power mode if we wanted to do a more comprehensive analysis. So for now, I'll just demonstrate quick mode. We've set the dimensions. Next, we can move to the materials. In the materials tab, we can choose the rotor core, rotor magnet, and stator core. In an induction machine, we would get to choose the cage materials. In a switch reluctance machine, we wouldn't have the choice of a magnet. So again, whatever the material properties that are in that type of machine, or whatever the materials used, is based on the type of machine analysis that you're working with. The Materials tab does have access to the full JMAG database, so we can see all the user materials, or all the materials that are available in the JMAG database, and we can choose the materials that are closest to what we want to work with. At the same time, we can also add custom materials into that database and then select those for our JMAG-Express analysis. Once we've finished setting the materials, we can move to the windings. One of the new features in JMAG-Express is that we have a phase resistance calculation. So now, instead of just specifying the actual phase resistance, we can go through and calculate it using either a round wire dimension or a rectangular wire dimension. The calculation will use the wire diameter, number of strands, insulation thickness, slot fill factor, maximum slot fill factor, and correction factor, and then look at the actual slot geometry to determine a phase resistance. So I'll just go back to the setting now. We can also select the number of layers, the type of winding, and the coil pitch. In the type of winding, we can use automatic, which is a distributed winding, or we can use automatic as a concentrated winding. If we have a custom winding pattern that we wanted to set up, we can also use the manual setting and then just select the go and return slot for that manual winding. The last tab we have is the drive tab. In the drive tab, we set up whether we want a current source, a sinusoidal voltage source, or a 120-degree voltage source, or basically like a trapezoidal drive. We set the amplitude of the source, any phase angle that exists, and the rotation speed. Now, everything has been set up in JMAG-Express, and we can click on the little light bulb button, which will calculate the results and give us that output, such as the torque versus efficiency, or the torque and efficiency versus current amplitude, copper loss and iron loss, in this case the D and Q axis inductance, torque constant, the rated current and the average tooth flux density, the magnetomotive force, and the current amplitude versus voltage. If we wanted to do an RT-based analysis, or create that RT model block, we would select that button, and then we would select the output directory and the type of RT block that we want to create, a Simulink electric signal block, current signal input, voltage signal input, PSIM block, or something for LabVIEW, for instance, for the National Instruments hardware-in-the-loop simulations. We can also kick the model into JMAG Designer to do the full FEA analysis. It would ask us to save the file, and then we can open it up later in JMAG Designer. The designer file that would be opened would have all the properties automatically set and could basically just run that full FEA analysis without having to go through and set any more properties. So that's a brief overview of JMAG-Express Quick Mode. So we'll go back now and to the presentation and go through the Power Mode. JMAG-Express Power Mode. Full FEA analysis based in JMAG Designer. The features of power mode are that parameters such as geometry, winding, and rotation speed can be set in template form. So effectively the same front end that we just saw with JMAG-Express Quick Mode, except now we're going to set full analysis scenarios to solve. JMAG-Express Power Mode uses the full finite element method to solve phenomena such as localized magnetic saturation effects, iron loss from harmonic current, and many other nonlinear simulation parameters. Results for Power Mode are displayed in a dashboard, and we'll see this again in the short demonstration at the end of the Power Mode presentation. The benefit of Power Mode is that we don't just run a basic output of some of the motor performance parameters such as what we saw in Quick Mode. We actually do a full analysis scenario. These scenarios are provided for PMSM, or permanent magnet synchronous machines, induction machines, and switch reluctance machines. The scenarios that we have available for the permanent magnet synchronous machine are a no-load analysis, a load torque analysis, an inductance analysis, and an efficiency map analysis. We can also do core loss analysis, joule loss versus frequency characteristics, and an iron loss distribution. We can also look at magnetic eddy current losses versus division, and the distribution of eddy current or eddy currents within the magnets. For permanent magnet synchronous machines, we can also do a torque separation and look at reluctance versus magnet torque separation and magnetic flux density distribution, both for reluctance torque and for magnet torque. For induction machines, we can look at parameters such as magnetic flux density distribution, current density distribution, secondary resistance, leakage inductance, and excitation inductance. Drive characteristics-wise, we can see primary current and voltage, primary and secondary copper losses, iron losses, torque efficiency, cage eddy current loss distribution, and core iron loss distribution. Torque characteristics-wise, we can look at torque versus current, current versus voltage, cage eddy current loss distribution, and core iron loss distribution. We can also run a line start analysis on the induction machine and see the starting speed and torque time variations and primary current time variations. For a switch reluctance machine, we can look at an I-psi characteristic, magnetic flux density distribution, linkage flux, inductance waveform, torque, and torque waveforms. We can also do dynamic characteristic analyses on torque waveforms, current waveforms, copper loss waveforms, and switching characteristics. Finally, we can see drive characteristics such as speed versus torque characteristics, speed versus current characteristics, speed versus iron loss characteristics, and speed versus efficiency characteristics. Again, JMAG-Express Power Mode is effectively just a JMAG-Express front end for a full JMAG Designer FEA. The benefit is that to reduce the calculation time, the analysis parameters for each scenario are defined by JSOL. So again, you choose the output parameters that you want to view that we saw in this slide, and JMAG will set the model up to generate those parameters. And again, this is a full FEA model, so nonlinear effects and saturation effects are going to be taken into consideration. Geometry creation, condition, and material settings are the same as in Quick Mode. Analysis parameters such as windings and rotation speed are simply entered according to the template, and editing standard geometries and adding your own custom geometries are possible just like as they were in Quick Mode. The other feature with JMAG-Express Power Mode is that the results are generated in a dashboard. These dashboards actually generate a searchable database that every analysis that you run in JMAG-Express Power Mode is stored. So you can go back and you can search this database based on the device name, the device parameters, calculation date, etc. to call up the results of the dashboard and perform additional calculations. Dashboard results can also be opened directly in JMAG Designer. So again, since the model results that are displayed are based on a full FEA calculation, clicking on any of the results will actually open up the JMAG Designer model. So before I get into the summary, take a look at how Power Mode works. So we're back in JMAG-Express, and we're looking at the same output screen that was calculated in JMAG-Express Quick Mode. So the model, we'll leave the same model that we had set up originally for the Quick Mode analysis, and we'll leave all the conditions the same. The only thing we're going to do is change it from quick mode into power mode. And when we select power mode for this permanent magnet synchronous machine analysis, we can see we have different analysis scenarios that can be run. We can choose to do a no-load analysis, and then we can determine, is this going to be an analysis that we want to run quickly or we want to run for maximum accuracy? We would set the rotation speed, and then when we click the light bulb, then the analysis would start running. So right now I'll click the little light bulb, and it's going to ask us to determine a project name, and I'll call this Test 2. And I'll put this into a folder that I've set up on my desktop. And click OK. And what's going to happen is that model is going to be exported into JMAG Designer for a full JMAG analysis. And so we'll wait a little bit here and let that get going, and we can see that now the analysis is running and we're getting the analysis progress bar. Before we get into the actual run analysis that was run, we'll look at some of the other scenarios. So we have the load torque scenario, where we can define a maximum and a minimum current and a number of divisions, and look at the torque at each of those divisions, and also look at the current phase angle and see how that affects torque. We can do an inductance map based on a minimum and maximum inductance and phase angle, or also generate an efficiency map. Each type of machine in JMAG Designer is going to have the set of analysis scenarios that were examined in that previous slide. So induction machine, switch reluctance machine, and permanent magnet synchronous machine all have different scenarios that can be run. So this analysis is running, and this will give me an opportunity to actually look at the virtual test bench database. So if we go into the database, we can actually see that some prior analyses were done in JMAG-Express, and these are all stored. So an IPM test 1, and then a type of scenario, and we can actually see, all right, well, that was located there. Once we define that scenario, we can go back into JMAG VTB and open up some of the previous analyses that had been run. And so it looks like the analysis is just finished. And so what we see is the results that are displayed in a dashboard. And we can choose to say that maybe we want only a single column, so we want to focus on the results, such as the no-load back EMF. That was a scenario that we just ran. And what we're going to see is I'll go back to setting the columns as 2. We can look at the no-load flux density distribution and the iron loss distribution, and we can see the cogging torque and that back EMF voltage. It also is going to give us the iron loss for the split into joule loss and hysteresis loss, and then again the total iron loss, and then some of the design parameters that were used for the model. So I'll set the columns back to 3. And so again, all of these results are ran in JMAG Designer. So if we click on any of the results, what's going to happen is it's actually going to open up the JMAG Designer model that was used to generate the results. And so now we are in JMAG Designer, and we can see that this is the no-load EMF plot, and we can see that it took 10 steps, and we can look at all the parameters that were used to generate this model. One of the nice functions is that we can actually copy these results and then use them as a basis for further analysis, or move them around as we would wish. So we can modify the parameters, and we can treat this as a fully independent JMAG Designer model. So as I was mentioning, we also have that the results dashboard that allows us to take a look at the previous projects that were run, and we can search that based on the case name, device name, etc. And then if we have previous scenarios, we can actually go back into JMAG VTB, and if you remember in that JMAG-Express project, I did a no-load analysis, but I've also previously run a load analysis. So we can go back in and we can open up what should be the load analysis, and we can see that the results for that analysis are displayed in our dashboard. And so now, besides just the basic no-load analysis, we have the load analysis. So we can see the current phase versus torque, the current amplitude versus torque, the current phase versus losses, and the current amplitude versus losses. If we click on a graph, again, we can go back and it'll open up the graph itself, where we can look at the data points that were used to generate the graph. If we click on any of the JMAG Designer based models, it'll go back again and open up JMAG Designer and open up that model in JMAG Designer. So again, we can go through and see the parameters that were chosen. So as you can see, JMAG-Express Power Mode is very similar to JMAG-Express, and that is template, or JMAG-Express Quick Mode, and that is a template-based analysis. But now, instead of just having the result display in a simple screen, we have the capability to run a full FEA analysis based on the different scenarios that we have available for each of the machine types. So I'll go back to the PowerPoint now and summarize JMAG-Express Power Mode. So the parameters such as geometry, windings, rotation speed are set based on a template style, and it has almost the same look and feel as Quick Mode. JMAG-Express Power Mode takes advantage of analysis capabilities and finite element methods for solving, so localized magnetic saturation effects, iron loss from harmonic currents, etc. can be evaluated. By choosing to use Quick Mode or Power Mode, depending on what evaluation phase you are in, we think it will prove to be a useful tool for your machine development. So in conclusion, JMAG-Express has been presented as an easy, fast motor design tool. Trial evaluations and benchmark tests are available, so please don't hesitate to contact us if you're interested. Thank you very much for your attention today, and if you have further questions or comments, please feel free to email us or call us at one of the following addresses.